Hi, welcome back. So in this video, I am going to be giving you a framework that you can use to help you solve problems or get your head around problems when you're solving them in programming. Now, when you're coding or writing a new app, usually there's a problem that you need to solve, or maybe you need to do something or complete a task. And sometimes you just cannot get your head around that problem. You've tried every way, you've tried writing it down, but you just keep scrapping your ideas and they never work. So if you're in that position, or if that's happened to you before, then I think this video could really help you. So what I'm going to do is give you a nice step-by-step layout that you can use to go through any problem, and hopefully that should really help. So before we get started, I'm just going to give some quick disclaimers because some people tend to interpret this the wrong way, and then they end up using it and it actually ends up hurting them more than it benefits them. So first of all, you do not have to follow this method exactly. That's the main point you should take away from this slide. You do not need to go through every step perfectly, following everything I say. It's obviously up to you and your confidence with the problem. If it's something easy, like maybe finding the minimum value in a list, then of course you're not going to need to go through all the steps. That would just be wasting your time. But like I said, it's all based on the complexity of the problem and how confident you are with it. So you're going to need to be the judge of that and see which steps you can cut out, which steps you need to maybe add in or spend more time on. It's all up to you and the problem. So let's go ahead and get started now. First thing we're going to be talking about is the actual problem. Now, when most people look at a problem, they tend to just skip over it, maybe skim it, not really look at it. And then they actually end up, making misjudgments about the problem. And that's when problems really start to develop. Now, this step isn't focused on what you need to do to solve the problem. This is more focused on the problem itself. What's it made up of? What do you think you need to do in the future to solve the problem? This is all about kind of setting up a framework so that in the future you can just fill in all those blank spots easily. So I'm going to show you an example of this. So this is a pretty standard, easy problem that I have written here. If you've had experience in programming before, then you should be able to solve this pretty easily. It's just a function that decides whether a number is odd or even. Now, in this step, what you're doing is you're not thinking about, first I need to define a function and then maybe run a conditional. That step is saved for later. Here, what you want to do is decide what you're going to need to complete the problem, how long you're going to take. Now, like I said, if you've been programming before, then this shouldn't take you any more than maybe a few minutes. But if this was a more complex problem, maybe it's a large application, a front-end framework, something like that, then obviously it would take you a lot longer. So here is about setting expectations. And like I said in the disclaimer section, you can actually use this hand in hand and decide what steps you need to take to get to the result. So the next step in this framework is analyzing examples of the problem. So first thing and the easiest thing to do is think of some examples that you can put into the problem and try and see what's going to come out. So what goes in, what comes out, the inputs, the outputs. What happens if we, use weird cases? So if we're trying to find odd or even, what if we put a string in or things like that? And although this may seem counterproductive and a waste of time, when you actually plug in or these examples, you might actually realize patterns and things that you might not have had you just gone straight and tried to code out the problem. So this is actually a really useful step. Now, what I recommend doing if it's a really large problem is actually write it down like I've done in this slide. So you can see here that I've actually written down, okay, so if we plug 5 into this function, it's going to return odd, right? And as we plug in 2, it returns even, and you can see that I put maybe an edge case there or an outlier. So if I put something like hello, it's going to return an error. We don't actually know what it is at this point. Now, of course, this will vary from problem to problem. So, not every function is going to need to take in a number. Sometimes it can be an array or some complex data structure, and it's completely up to the problem. The main thing you need to take away from here is being able to plug in examples and start trying to figure out the dynamic of this problem. And this actually can lead you straight to the next step, which is visualization. So this is where you actually start, getting deep down in the problem and trying to think of ways you can solve it, although it's quite abstracted. It's not really down to the details, and it's not really turned into any language yet. This is kind of the logic or the flow that you need to take to get to the solution. So pretty much you have to try and imagine what you're going to do to get to the solution. Now, in most cases, this is actually the hardest part. Most people would think coding is the hardest part of any problem, but what's actually really hard is thinking about what to write. So like I said, what you can use to help you if it's a really hard problem is you can use flowcharts, diagrams, sketches, and of course you can use anything that, suits you. So for example, some people prefer getting a whiteboard out and drawing some diagrams or some some illustrations, and some people like using flowcharts and other, the visual tools that they can use to kind of plan out what they want. So like I said, from the examples that you created in the last step, you're starting to notice some patterns. So for example, you can say, hey, if a number is divisible by 2, then it would turn out to be an even number, or whatever the problem is. But like I said, what you can use is you can use that in this step to create your flowchart. So this is a little example I created for my odd or even problem over here. And of course, this isn't, perfect or anything, but what it's showing you is kind of the thought process you need to go through in order to reach the solution. So for example, we have a function up here, and then we insert a number. Now, although this may seem, trivial for most programmers, actually writing it down can really help you. All those trivial cases, those things that might seem obvious, it actually really does help to write them down, because once you get all that down on paper, you can easily transfer it onto your problem when you're writing it. So like I said, this can vary from problem to problem. You can have different structures. But again, like I said, it's all up to the problem. The next step is pseudocode. So if you don't know what pseudocode is, it's pretty much a way to represent programming without actually using the language itself. So this is kind of a general way of laying out things like functions or programs without actually writing any code. So for example, instead of having an if statement, you would put a comment and say, if this is true, and then you would do something. Now, of course, it's not perfectly accurate, and it won't run if you put it into the language, but what it's supposed to do is represent the idea and kind of like a placeholder, and then later on you can go and solve it. So like I said, you take the visualization or the sketch that you had and you start really building it in detail. Now, this can be, tailored towards the language that you're using or the specific context. So if you're building it on a large application, it's all up, like I said, to the problem and as well as the environment that you're solving the problem. So if it's just a, simple coding quiz, or if it's an industry application that you need to solve the problem for. So you should use common programming terminology and concepts in your code. So things like loops, conditionals, data structures, anything like that. Try and include as much programming terminology as possible in your pseudocode, because it's really going to help you later on when you start writing your actual solution. So this is an example. This is in Python. You will see that in the next slide. So you can see here that we have the function definition takes number. Now, of course, this isn't going to run at all. If we, put this into Python and try and run it, it's just going to throw back a syntax error. But it does represent the context of what we're trying to do. We're trying to define a function that takes in a number. And although it might be written differently, that's really easy to do once we read it. And of course, and then we have our little logic flow structure here. And if I actually go back a couple of slides, you'll see, now ignore the outlier cases for now, but you can see that it says odd or even, the function, conditional, return even, conditional, return odd. And if we go forward back to our pseudocode here, you can see that we have conditional even, conditional odd. It's just a little bit more detailed. So you're kind of building up the solution step by step, detailing it every step of the way until you finally come to the solution. So the next step, and well, although it may seem like the most important, it's actually not in the grand scheme of things, and that's actually solving it. So this is where you're actually writing the problem. So what you would do is take your pseudocode, and kind of convert that into your language. So if you have, maybe you're writing it in Java or C++ and you have your basic pseudocode, and you would convert that into something that would run in the language. Now, of course, it is natural to struggle with some steps. You may not know all of the keywords or the operators that you need to use to get to a certain place, even though you know exactly how and what to use. So if you are struggling with a step, use any resources you have. You can use the internet. If you have coworkers or friends around you, you can ask them. And the great part about pseudocoding is if you really are struggling with something and can't find help for it, you can always just leave it out for later, because pseudocoding basically allows you to split up the steps. So if you have your little flowchart there, you can do everything except this one thing where you have to use an operator or a keyword that you don't know at the time, then you can just leave it in pseudocode form and change it later. And that's going to get on to the next step, which I'm going to cover in a second. So you can see here that I have our pseudocode at the top, and then we have our actual Python code here. So for example, function definition, we convert that into an actual function definition, which takes in a parameter of number, which is just num as represented here. And then we have our little conditional. So if the number is divisible by 2, return even. And you can see that that is also converted with our new operator. So our modulus operator, we're equating the two sides, trying to see if it's true or false. And you can see this is just going to run as code here. So the next step before we get to refactoring is debugging. Now, debugging is pretty important, especially if you have a larger application, and sometimes bugs may not always show up in the form of an error. It may be something that works perfectly valid, it's perfectly valid, so the syntax is correct, but it doesn't actually, logically, it doesn't work. So there's a kind of system that I like to use for debugging, and that's kind of the top-down approach. So you start at a very high level. You don't really look into the details. What you're trying to do is look for silly mistakes, pretty much. So things like spelling errors, maybe a misplaced character, things like that. So this is where you skim through your solution looking for any of these. Now, although you may think that you would spot them instantly, it's better to skim through it a few times, because sometimes you're skimming through it very fast and you actually miss those characters. So I'd recommend looking through it very slowly and trying to find any of these characters. If nothing works, try and look for error messages that you get in your solution. These error messages can actually really help you. And although it may not seem like it, and maybe it's just a bunch of, gibberish to some people, looking and actually studying these errors can actually really give you some insight into where your problem's located. So for example, if it's a value error, then you might know that maybe you're converting something from a string to a number at some point, which would really help you hone down your search area. So it's not just error messages that can help you. Unexpected results, so logic errors in this case, can also help you too. So for example, if you're trying to return if something's even or odd, but it's not returning anything, it's just returning undefined or none every single time, then that can actually really help you. Maybe there is a little conditional at the top where you're returning none and it's always giving that case. So like I said, those error messages and those unexpected results can really help you. And if you can't find these errors, or if the error messages aren't helping you, look deeper into the logic of the code. Try and run through it step by step in your head, trying to see, okay, this thing happens first, and then this, and then try and look if that happens in your code. And sometimes, well, in this case, most of the time, when you're looking through it and you say, hey, that's not supposed to work like that, and then you start realizing those errors. Now, this can take maybe less than 5 seconds to find your error, maybe just a misplaced colon, or a semicolon, or a misplaced character like that. Or it could be something very deep, a complete logic error that you need to completely rework your solution. So that's kind of my general rule for debugging. Now, of course, you can vary this based on, what you find best. If you can really spot problems easily, then if you're a really good, problem solver, if you're a good debugger, then obviously you can run through this pretty fast. But like I said, it varies for some people. So this is the code right here, and it has a little error in it. So let's go ahead and use our strategy there. So first thing we're going to do is skim through and try and see what's going to happen. So let's go ahead and run through. No spelling errors, nothing here. That's fine. There is no spelling errors or misplaced characters. So now we know that something's up. Now, what are we going to do? Well, once I run this program and I enter any number, it's going to return even every single time. So we know this is a logic error. So now let's go ahead and try and hone down our results. So this is how we kind of want our logic to work. If the number is divisible by 2, we're going to return even. If the number isn't divisible by 2, return odd. So let's go ahead and run through this one more time. If the number is divisible by 2, return even. Okay, that's good. But what if it's not divisible by 2? Well, if you actually look at this, it says else if num mod 2, which is if this is divisible by 2. This is an equals. This is saying if the two are divisible. So pretty much what's happening here is we're actually basically going to not do anything if the number's odd. It's just going to return even for all the even numbers. And then if it's odd, or if we put an odd number in here, if it's divisible by 2, which it isn't, move to the next case, if it's divisible by 2, which it isn't. And then it just runs through the function and will only give us the answer for the even numbers. And you can kind of see the clue there. If you look back, it was only returning even for every single number. So like I said, you can use those to your advantages and to your advantage. And if I actually go ahead and show you the solution here, we do have, there is supposed to be our mistake. So there's a little run through of my debugging method. The last step I want to talk about is refactoring. Now, refactoring is pretty important, and although most people don't really place it in high regard, it can really completely change a program or a solution. Now, I actually wrote a blog post on this about, expectations in programming or trying to write the perfect solution. And it's actually in the description if you want to go look at that blog post, and it talks about this a lot. Most people try to go for a perfect solution on the first try, something like a golden solution that captures computer science concepts perfectly or is super efficient. Now, what I said pretty much in essence is you have to work on it now and refactor later. And that's what I'm going to be talking about now, is actually refactoring. So if you don't know what refactoring is, it's pretty much just reworking your solution or adding things to it to make it better. Now, you have to look for ways that you can optimize your solution, but you always need to keep the golden 3 in balance. And the golden 3 is pretty much readability. So if you can read your code, if you can comprehend it, if it's easy. Now, readability isn't that important in some cases. So, if you're just writing your code and storing it in a code base somewhere, middle of nowhere, then obviously readability isn't going to be much of a factor. Efficiency, which is, well, how fast does it run? How much memory does it take up? And compatibility. So this is if you can use it in combination with other, maybe other inputs, other functions. And of course, an example of this would be if we have a function that only checks if the number 3 is even or odd. Now, obviously, that's not very compatible because we can't use it in anything else. But once we change it to any number, we have this huge useful function that we can use to test if a number is even or odd. And you can see that compatibility is pretty important. So you have to keep these 3 in check at all times. Obviously, you can prioritize one over the others in certain cases, depending on your circumstances, but it's kind of just a rule of thumb to keep these in check all the time while you're looking for them. So don't go completely overkill and try and write your entire solution on one line, but don't also make it so inefficient and yet so readable. So just always keep those in balance and, of course, vary them slightly depending on your circumstances. So here we go. I'm going to go ahead to the next slide, and we can see here that we have our old solution and our new solution. So if you remember back a few slides ago, I talked about our edge cases. So things if we inputted a string, if we inputted maybe a list, and pretty much what this is going to do, this little refactor, which is actually goes under compatibility, is it's going to check if there's an error in the value. So it says it's a try except block. So it tries this, and if a value error, so if it's not a number, is returned, then it prints please enter a number. So this makes it a lot more compatible, and it also makes it a lot stronger. So this is a much stronger function. And that's pretty much the essence of refactoring. There's really not much to it, but you always have to consider the fact that refactors can completely change your solution. And sometimes refactors are so big that they can be considered whole separate problems of their own. And if that's the case, if you really think it's worthy of a problem, then you can always just use these steps again and go through the framework step by step, starting by looking at the problem and then, trying examples, all sorts of things like that. And you will eventually get to a really good refactor. So if you want to go read more about that blog post talking about why refactoring is so important, you can check it out in the description. So that's pretty much it for our little solving problems framework. So this is kind of the step-by-step guide that if you can use it and master it, then it can really help you solve some problems. All right, thanks for watching. I just wanted to let you know that there is less than 1 month left to get your entries into the creative coding contest. You can win up to $100 by submitting your most creative coding apps and ideas, no matter how big or small. You can go check out the video in the description if you want to learn more.